All right, so I'm going to talk about cloud native WebAssembly, and promise I will try and tie that into NATS at some point. So before I get going, I just want to take time to shamelessly self-promote my book. Earlier, there were some talks about Rust, and as you'll see, some of the samples that I'm going to go through, the samples that I've got are in Rust, although some of the demos also have assembly script samples. We mentioned a tiny bit about WebAssembly earlier, but the basics are that WebAssembly is not JavaScript. It's a stack-based virtual machine. It's operating system and processor agnostic, and I think those two characteristics are some of the most important ones when it comes to running it in the cloud. And like I said, it's not just for browsers. WebAssembly works anywhere that the host and guest can agree on a contract for how to communicate. And in one of the earlier sessions, I forget which one, there was mention of NATS wanting to have the ability to execute WebAssembly for custom logic. And as long as NATS and the guest modules agree on a contract, they can do that. So the project that I'm working on is called the WebAssembly Secure Capabilities Connector. And it's essentially a way of running WebAssembly in the cloud by dynamically connecting your WebAssembly module, or what we call actors, to cloud native capabilities, one of which is NATS, but other ones are things like key value stores, SQL databases, HTTP servers, all of the things that your applications tend to need when they're running in the cloud. Security, those of you familiar with the NATS 2.0 security model will find an awful lot of what I'm doing with signed JWTs to be suspiciously familiar. It's basically because I ripped the idea from Derek. The actors are flexible, and they're the point that I think aids in some of this productivity that we want to give developers in the cloud is that the capabilities are dynamic at runtime. So you can swap actors in and out at runtime. You can swap capabilities at runtime. So I can take NATS and replace it with some other message broker. Not that I ever would, but you could swap Redis for Cassandra, things like that, all at runtime without ever having to redeploy or even recompile your actor module. And again, I'm going to try and keep things moving as fast as possible. So if you want to take a look at the documentation, it's wascc.dev. There's a number of different aspects of the WebAssembly connector project that I'm working on that I normally talk about, but I think I want to focus on removing boilerplate from the developer experience. And so when we're building our cloud native applications today, we have to worry about an awful lot of stuff, more than just the business logic that we're writing. We have to worry about HTTP servers and standing up web-based endpoints. And if we're deploying in Kubernetes, we have to worry about that even if our application doesn't even serve HTTP, because we need to be able to deal with exposing health and readiness endpoints. We need to connect to databases. We probably have to deal with caching at some point, message brokers, security, resiliency, monitoring, tracing, essentially a bunch of the things that we've already seen sessions on today. We need to be able to scale our applications up and down. We need to be able to turn them off if we can to save money and resources. And we also have to figure out how to actually bundle these applications and deploy them. And there's a tiny little bit in there, usually about 10% of the time we spend, that's covered on where we actually get to spend our time writing business logic. And what we should be spending our time doing is worrying about the business logic. We should spend 90% of our time writing features and then only 10% of our time dealing with the rest of the stuff. And it's our hypothesis that we can use some of the limitations and the benefits of WebAssembly, especially the sandboxing aspect of it, to give us the ability to worry about just our business logic. And so today, developers have tons and tons of tools. In fact, I think we probably have too many tools right now, especially if we're dealing with Kubernetes. We're essentially given, you know, as the picture shows, we're given these buckets of plastic beads and told to melt them into whatever shape our application needs to be. And it works well, but, you know, and we end up with these bespoke applications that do what we want them to do. But I personally don't think that's the right abstraction level to be building our applications in. What we really want are Lego bricks that we can reuse and plug together for one purpose and then pull them apart and put them together again for a different purpose. But today we're all essentially, you know, melting our own bricks before we actually get started building our Lego houses. So what I want to do is show a demo of WebAssembly in the cloud. And what I'm going to show is a microservice that listens to a NATS subject, and every time it receives a message, it adds to a counter that it's storing in a key value store. And it also exposes over HTTP a JSON endpoint that gives you the current value of that counter. And as I go through the demo, I just want everybody to try and keep in mind the amount of boilerplate and the amount of you know, client code that they would have to copy and paste and throw into their project in order to make this thing possible, even though the business logic is really, really small. The business logic should be a few lines of code, but you know, from having written this type of thing in Go and C and Java and a bunch of other languages, the business logic usually ends up getting hidden behind all of the stuff that we've had to copy and paste. And hopefully we can make that change. So let's see if I can get Visual Studio Code to show up here. So hopefully you can see this. Did this get cut off?
No, we can see it.
Okay, so this is the entire contents of my microservice. Let me just see what's going on in chat here. Okay. Yeah, so in my service, I'll highlight it so you can see here. I've basically just defined the list of messages that my WebAssembly actor responds to. And in this case, an HTTP request, a health request, and a message from the message broker. And what's not shown here is how the HTTP request is delivered, how the health request is delivered, or how the message broker delivers the message. All I'm declaring is my intent and not how that intent is implemented. The non-functional requirements are nowhere to be found in my code. And so this function here just returns some JSON that gets the current value of the counter. And the current value of the counter comes from my key value store. And this could be, again, this could be any key value store. My code is not tightly coupled to which one. I'm currently using Redis, but like I said, I could use an in-memory one. I could use Cassandra. I could use anything that conforms to this key value contract. The handle message function, this is the one that I've set up as my message broker message handler. This will respond to a NATS message, and it just adds one to the counter. And again, calling one key value function with no boilerplate. And finally, just the health request, the health handler. And if I return Rust's OK, that tells the host runtime that my WebAssembly module is functioning the way it should. So, oops, pretend you didn't see that. So the first thing that I would normally do is I would build a release version of my WebAssembly module. And again, as I mentioned earlier, I've completely stolen my security model from NATS. And so if you look at the WebAssembly module that I produce, yep, this is why nobody ever does live coding. So I'm examining the signed JSON token that's inside the WebAssembly module. It's embedded directly in it. So one thing that we can't get with Docker is we can't bundle the capabilities and permissions of that Docker module or that Docker bundle with the Docker file itself. Its capability attestations come from somewhere else. And with it being embedded in the WebAssembly module, this portable module has the same list of permissions regardless of where it goes. And so you can see that it's been granted the permission for a key value store, messaging, and an HTTP server. And again, if you've been paying attention to the NATS 2.0 security model, you'll see that these look very suspiciously like N keys. And again, that's because that technology is completely stolen. Oh, that's perfect timing for a phone call. So let me just show the code for the host runtime. The first thing that I've got is a host manifest, and the host manifest is just a YAML file that describes which WebAssembly modules I'm going to load into my runtime host. And these are actor bindings. And so I'm binding the actor that is identified by this public key to the messaging capability with the subscription and this URL. And note, this capability doesn't actually say NATS anywhere. The assumption is that that capability is going to be satisfied at runtime, and that anything that conforms to this capability contract is a suitable replacement. I'm also binding HTTP server on port 8080, and the key value store is using this connection string. And the host code to build a binary that loads those actors and those capabilities is, again, just a couple lines of code using the WASC host GitHub project. So what I can do is run the demo host. And you can see that it has loaded HTTP server provider, messaging, key value. You can see that actor binding has been taking place, and that it has a web server started on port 8080. So if I publish on the subject that thing is listening on a couple of times, you'll see that it received a host call, that this actor handled the message that I got from NATS. And now, if I hit the web server for that, I now get some JSON that actually has the current count. And again, this is a microservice that compiles down to a portable file that doesn't need to be rebuilt to run on different architectures, doesn't need to be rebuilt to move between a Raspberry Pi or a Docker image or Kubernetes. And one other fun fact on these WebAssembly modules. I always forget what order those doing, it's 2 megs. So this microservice that runs an HTTP server, listens to a NATS topic, and communicates with an atomic counter inside a Redis database, consumes less disk space and less RAM than an animated GIF. And see if I can get back to the slides. Okay. So why is this related to NATS? I think earlier when NATS was compared to plumbing, I think that's pretty accurate. I think it was at KubeCon, there was a phrase people started using where they wanted boring infrastructure. They wanted infrastructure that wasn't exciting and stuff that they could just forget about. I want infrastructure that is a light switch. If I switch it on, I want the lights to turn on and I don't want to have to worry about it anymore. And of all of the things that I have to deploy in order to get my applications working, NATS is always the thing that I don't worry about. I can spend some time building NATS-based architectures, but in terms of which piece of plumbing works, NATS always works. And so when I had to figure out which capabilities I was going to give to these WebAssembly actors first, NATS was the first one that I wrote, because you can use NATS as one of those Lego bricks to build other things. And so being able to have that as a first capability was important to me. And so like I said, it's that piece of infrastructure that I never worry about. And so that was all I had.
Thank you, Kevin. I'm always inspired by how Kevin kind of tries to push the envelope. And for those that know a little bit about me, know I spent a little bit of over a decade of my career in deployment platforms, right? With mostly around platform as a service as kind of an interesting one. And not only am I excited about Rust, as we talked with Tyler early on, and WASM, which I think Kevin is highlighting. And again, he's way ahead of the curve. I think he's waiting for WASI and initiatives like that to kind of catch up to some of his thinking. But I will put a little observation out, and I'm normally wrong, so don't feel bad if you don't agree with it. But platform deployment technologies don't get replaced by newer, better platform deployment technologies. They get replaced when the unit of deployment changes. So, for example, going from a VM to an application was from VMs to applications in the birth of PaaS. PaaS seeded back in terms of, hey, we want to have a little bit more control and we want to go more back to an IaaS. But the reason that all of a sudden it succeeded and things like Kubernetes, I think, came into being was because we moved to containers, right? Docker, but containers. And I think, and again, this is just my observation, that that trend continues to happen. OpenStack was VM, tried to make the jump to containers and really didn't, right? It was left behind. I think WASM and the ability to deploy these things at scale securely with very minimal resources is going to be that next major transition in deployment platform technologies, because we're going to change the unit of deployment. So definitely keep an eye out for the stuff that Kevin's working on and some of the ecosystems. It's still very, very early. Kevin's running ahead of a lot of folks, but I'm really excited about where it's trying to drive us. And again, for me, I just try to focus on simple and predictable, right? But if we change that unit of deployment, I think you're going to see some changes in the encompassing technologies, right, that do the deployments today. So, Kevin, thank you. I really, really appreciate the time. Great talk.
My name is Ron Britvich. 25 years ago, I worked for a company called Worlds. We developed a virtual reality platform for sort of like the early MMOs. We did, took that as far as we could take it. And I said I didn't really want to work on anything else new until there's some major new technology that comes out. And what we're seeing is coming soon is the concept of AR glasses are going to be available. And that, you know, it's probably a year or two away, but it's really a nice new way to see the internet, because the internet today, you can't really see it in your world. You have to go to a screen to see it. And so we wanted to develop a platform where you can put the internet into your world. You can see it, you can touch it, you can feel it. You can, you know, eventually you'll be able to smell it and whatever. So this is the journey that we took to create this. And so the problem we have is we're trying to create a social AR platform, and we want it to work with, you know, handheld devices and AR glasses that are coming. And it's a pretty complicated problem to create a distributed computing platform that can handle the kind of growth that, you know, we expect it to have in the future. One of the things that, you know, we want is obviously something that's very scalable. It also has to be secure, you know, if we're doing transactions and things. And we, in an AR type environment, we need very low latency. It has to be able to handle tremendous number of messages per second. And we also run in what's called an authoritative environment, where the services are the final say, and they tell us, you know, what, you know, they make sure that users can only do what they're authorized to do. And we're also very interested in the location independence of the services, and we want a system that's very resilient, self-healing. It, you know, we don't have to just constantly be monitoring it. So the first thing we had to do is choose a client platform. And right now, the major clients for AR are Apple's AR kit. Microsoft has the HoloLens, and they have a whole development kit around that. And then Google has their own AR core development kit. The problem is we don't want to write specific code to each of these different platforms. So we chose Unity. It's a VR, AR type environment platform that has a thing called AR Foundation. And what it does is it unifies the platform code so that we can write one set of code and it works on all these platforms. And as future platforms come out, it should work with them too. Next thing we had to do is choose a networking platform. And so we looked at Unity's networking. They have an older system called UNet, and it's only designed for up to about 24 users, because it's peer-to-peer. It uses UDP. It's also deprecated. They don't really want to support it anymore. So they've been working for the last couple of years on a new thing called their netcode, and it's designed. You can get up to like 500 users, but it's not available yet. They've been talking about it for quite a while. So it's not going to be a solution that we could use. And 500 users also is not the kind of numbers that we're looking for. We're looking for millions of users. So what we took a look at gRPC, and found that it could do most of what we wanted. We actually did the first implementation using gRPC, and it worked pretty good until we started facing some of those scaling issues. And as Derek said, the problem with some of these technologies is it's like you're calling your home phone when you want to call your cell phone, and be location independent. And that is a problem with gRPC. You're constantly plugging in IP addresses, and it doesn't really scale out either easily. You can't just start creating extra servers, to manage the load. Not particularly resilient. If one of those servers go down, you've got to write all the code to get it up and running again. And so it doesn't really self-heal. So then about 6 months ago, I came across NATS for the first time, and I was like, well, this looks interesting. Watched every video I could get my hands on from NATS, and realized that it actually solves some of these really complex problems that we were facing. Is it does have that location independence. I'm calling my cell phone, and that's exactly what I want. I can scale it out real easily, and it's designed to be self-healing right from the get-go. So I created an architecture topology like this. And so here, what we can do is have, millions of clients appear talking to a cluster of NATS servers. And for example, this might be on the United States side of things. And then those talk to these services that we have. There might be an avatar service. This is to keep track of where people are at. A property service. This is the objects in the real world and where they're located. A citizen service for managing identity and rights that different users have. And then on the other side of the globe, we can have the same thing and then create a supercluster across these continents, and then the various services can talk to each other and through this supercluster, and they can keep, for example, the citizen database up to date across the cluster, and the property and things like that. So this I was like, wow, this is fantastic, because now I can have very low latency here. I'm now using subject-based, pub sub, and many of the difficult problems just went away as soon as we did this. So we had to come up with, the set of subjects that we want to communicate with on. And so we have the citizen service, the avatar service, and the prop service. And so we created just some simple subjects. So citizen.immigrate, when you wanted to immigrate into the system or log in an existing user. The avatars, they need to tell their pose and say things to other people and select objects and things like that, and make offers. Like a bot may need to offer, various choices to a user. And then on the property side, you need to be able to add things to the world, look around at where you're at, move, and remove objects from the world. So the world can be multiple things. So an example might be a real estate world. This is homes for sale. And so you might add various items about a particular property that's for sale, descriptions about it. As you're walking through the house, you can actually see things that are left by the realtor to tell you about features of the home, for example. You could have other worlds too, maybe a location of different garage sales and what kind of items they have for sale. So you could quickly take a look at that. Maybe you're doing an infrastructure type app and you want a database of all the potholes in your city. You know, that's the kind of different worlds you can have. And the design of our platform is that you can be viewing multiple worlds at the same time and interacting with them at the same time. But what's important is to not have the clients completely overloaded with things that are happening way far away from them. So if I'm here in California and I don't really care what's happening in Paris, France, someone's building something at the Eiffel Tower, for example. I'm only interested in what's nearby me. So we have this concept of cells, and the way we do that is using NATS, we subscribe to just the cells in our immediate neighborhood that we're interested in. So let's say we're at Disneyland, for example. This is a map of Disneyland. This is the very center of Disneyland, the hub. And let's say we're standing here in the southeast corner of this hub. What we would do is subscribe to the latitude and longitude coordinates of that cell to 1/100th of a or 1,000th of a degree of accuracy. So that particular cell is 33.811 north and 117.919 west. But we also subscribe to the other 8 surrounding cells so that we could see things in the distance as we're walking through there. And with NATS's subscription model, we can easily just indicate what our area of interest is by subscribing to a subset of all the cells in the whole world. So if I'm in Disneyland, I'm not going to hear messages that are happening in Paris, France. I'm going to just hear what's happening in my local space. So the services, they subscribe to, depending on the service, to various messages, and we also use queue groups so that as the load on various servers get too high, any one of the queue group can handle the message. And then like a property server, they would subscribe to as things are added or people are looking around. They also will publish what changes that have been approved by the authoritative servers and publish those events. The clients will, again, subscribe to just cells that they are interested in, worlds and cells that they are interested in. You can see that. And then one of the next things we had to choose was what kind of protocol we wanted to use. We ended up looking at various ones such as JSON and protobuf. We ended up choosing message pack for C# with LZ4 compression. You see it has one of the fastest serialization and deserialization speeds, and It also has one of the smallest sizes for messages. So that ended up being good. To define the protocol using message pack, all you have to do is define these structures. So like, for example, here, if I'm adding property and I need to define this event, I just give it 3 keys that I want and set the things up. And then there could be other things like an add request, an add reply. And you notice there's a property in here. These can be defined also even as an abstract class, where you have the base class, and then you can use a union and extend that class to create more complex objects. And so to use this in Unity, it's pretty simple. All you have to do is call into our services SDK, and you'll notice one statement I wanted to highlight is this don't destroy on load. When you're using Unity, you want to make sure to call that when you start up. The awake is the way you start up. And what that does is make sure that as soon as I load another scene in my AR experience, all of this setup doesn't go away. If you don't do the don't destroy on load, as soon as you load a new scene, the whole system will fall apart. It will just lose the connection to NATS. And then this is a simple, connection up to NATS that is very typical. To call a service, you just, for example, new up a prop service. You can add like an event handler. Like when somebody adds a piece of property, you want it to call this event handler. And if you want to add property, you just do that, and you notice it's using NATS's asynchronous system, where you can just await on that, and it's very simple. There's no callback hell or anything like that. I use async and await in C#. When you call into like a prop service, what it does is it just takes the parameters that we have. It creates one of these event protocol objects, and then it publishes it out using NATS. As you're creating an event handler, similar. If you're adding requests, again, is similar. And these call in finally into the asynchronous messaging handlers for NATS. So here I'm subscribing asynchronously. Here I'm publishing using the NATS connection. And here we're doing an asynchronous request. And we're doing, this also is doing the serialization and deserialization as the messages are coming in. So it's pretty simple. And then to write a service, finally, this doesn't even have to be in Unity. It can be just regular C# code. And in fact, it could be even other languages. You just new up one of these prop services. In this case, I'm subscribing to everything, all the prop messages. And then as a request comes in, I just have a handler here. Here's someone wanting to add property to the world, and I just process it. And you notice here, I send it back to all people that are interested. And then I tell them that, yes, you successfully added something to the thing. So that's it. That was our journey creating this world's augmented reality platform. We're so glad to have NATS that it helps us get over all these different problems that we were facing with the other solutions. And if you're interested in developing services or bots or different applications for Warp, we call it, the world's augmented reality platform, contact me and I can hook you up with our SDK, and it will allow you to really easily, create your own augmented reality experiences using our platform. And that's it.
Ron, thank you so much. This, I remember you showing up and working with Colin a little bit on some of the integration points, and it's just a fascinating project, and I'm so happy that we can help out in a little way to what you're trying to do. But it's really, really a cool project, and thank you for taking the time to share it with us. I really appreciate that.
Well, thank you for NATS. And working with Colin has been great, because we had a few problems with Unity and we got them worked out. And so, yeah, it's been a great experience.
Yeah, no, and I know he was working with you, and I was talking with him, and he said, this is something that we don't think, we wouldn't have thought earlier on that NATS would necessarily be applicable to, but using your expertise and your domain expertise, and saying, oh, I think I can make this work well. It was really fun to watch. So again, thank you.
Oh,
Yeah,
my
this is an
pleasure.
awesome project. Thank you, Ron.
So when NATS 2.0 was being designed around this abstract goal of connecting everything, right? With large scale global topologies, security models, multi-tenancy, things like that. When we actually launched it, it was kind of interesting. There was some tooling that the team had written and some that I had written that were just utility applications that we would spin up and again, query state within our global network, NGS, which some of you have had a chance to look at and play with. And what I found was we were going into holiday break. We had just launched it. All of us were dead tired from launching at KubeCon, and I think it was 2018, 19, not sure. But I noticed that, with our very forward-looking security, which I think is a good thing, what I was starting to experience was this notion of, wow, it takes a while for the utility to come up, establish a TLS connection to a dynamic DNS entry, do the notch challenge key exchange, the JWTs and all that are part of NATS 2.0's security model. And so going into holiday, I started thinking about, hey, how can we kind of fix this? Maybe there's something that's missing. And so Leafnodes were kind of born out of, hey, I want to try to solve this one specific problem of amortization of the security and TLS constructs and setup. What happened though over that break, and subsequently with a lot of input from a lot of the NATS ecosystem and the NATS maintainers and team members at Synadia, was that it was kind of the missing topology link that we needed. And so what I mean by that is NATS already has multiple server connection topologies. And what I mean by that is connection topology is, I'm speaking specifically about how servers talk to other servers. Almost 10 years ago when NATS was originally created, it was a single server, right? It was a, let's get this thing up and running and go forward in terms of some of the stuff we were trying to do at the time with Cloud Foundry. And then we quickly introduced the notion of a route, which is a cluster, right? It forms a cluster of servers, and it's akin to what most people consider distributed systems today, which means, yes, there's multiple components working, but there's an underlying assumption, which is a bias, and maybe not necessarily a good one, that says, well, I assume that the signal noise is pretty good, the RTT is pretty good, and the bandwidth is pretty decent, meaning I can run inside of a region or availability zone in a cloud type stuff. But if you want to really stretch me out, that doesn't really work very well. And most of the distributed systems that are in our language today, Kubernetes and Kafka, are like that. They don't like to be stretched from East Coast to West Coast or to Asia Pac or to Europe. And to be frank, NATS was the same way with its initial clustering algorithms. And so in NATS 2.0, right, we introduced a second topology of how you can connect servers together called gateways, which are extremely tolerant of very long RTT, low bandwidth, spotty connections, low signal to noise type of scenarios. Leafnodes then joins that group of connection topologies that says, hey, this can actually be a hub and spoke. So you can treat something that looks like a NATS cluster or a supercluster or even a single server as a hub, and you can actually drive spokes, as many as you want. You can daisy chain them together to your heart's content. And so Leafnodes specifically introduced that topology change, or topology addition, I apologize. But they also do something that's really interesting, which is they allow us to bridge operator and security domains. And this one is very subtle and nuanced, but it's extremely important for a lot of the new things that you're seeing today, from the WebSocket support to MQTT stuff that we'll be talking about a little bit later on, where I can say, hey, I want to have a shared utility, either inside of a company, an organization, or like Synadia is trying to do, a global, shared utility. But I also want people to be able to extend it to meet their own demands and have servers that they're going to run and operate. And they might change security mechanisms on those domains. And again, we've already seen a little bit of this. It wasn't necessarily obvious, but WebSockets has a slightly different security domain where they're treating JWTs that are handed out as bearer tokens versus public claims. MQTT has its own security model, right? And so this property of a leaf node will allow us to do some very, very interesting things where you can mix and match utility SaaS with owned and operated, even inside of individual companies, where companies struggle to go from lots of silos of technologies to someone raises their hand and say, well, what we really need is a shared utility. All of us can share the same Kafka cluster. And a lot of times those technologies struggle at taking on that identity. And we've put in a lot of hard work, and the ecosystem has been amazing in helping us out to try to realize all of those other pieces that needed to be in play to get to where we are now. And it's interesting because the security model, even though you can change the security domain, the security model is cohesive, and it's the same one all the way throughout. And I'll kind of show that in a quick little demo of what I mean. A single server can have lots of leaf node connections, and I'll show that as well. And leaf nodes can be daisy chained together, right? So we've had certain people say, oh, I'm going to run a central hub, but I want to have lots and lots of connections. And these were actually out to, let's say, web or mobile. And of course, now we have WebSockets that can secure that. But that could be a very legitimate architecture of a single server cluster or supercluster that then has lots of hub and spokes to actually take on all of the inbound clients from a mobile application or a web application. And so they're very, very versatile. We've noticed that most of the large POCs we've been doing today, we're using them in almost every single one. So I think of it as the best of both worlds, multiple operators, multiple security domains, mixing shared utility with owned and operated. It's not an or conversation, it's an and. You can do both at the same time. And so we're really excited about where they are. They're still early on, and we're still, really trying to work with lots of different users and people working in the ecosystem to utilize these in ways that we might not have thought of. So it's been a great progress for the last, I'd say, 3 to 6 months. So again, a leaf node, we start with the notion that, at least from the original NATS 2.0, where a NATS system can be a single server, can be a cluster, again, maybe on a per region basis, or a supercluster, which is the way we connect clusters of clusters that Wally demonstrated when he was talking about some of the Kubernetes stuff and the Helm 3 updates that we were doing. And so what happens is that now leaf nodes can extend that, and it's a traditional hub and spoke type of scenario. And here we can see we actually have 3 different servers. And what, again, is very interesting just about even the simple diagram is that, this again could be a single server, cluster, supercluster. This can be a single server or a small cluster. It doesn't have to be a singleton, right? And thanks to Ari, who I think is getting some well-deserved sleep now since he's in the European time zone, pushed us early on to say, hey, I want to have a small cluster, and I don't want to have a single gateway and leader elections and single points of failure. And so this model right here, where every single one of those NAT servers is configured exactly the same way to solicit a connection to the NAT supercluster, right in the middle, work independently. They self-heal themselves independently. And so there is no single point of failure in that type of a setup. So we think that is extremely powerful as well. Now, what's interesting is that we can mix and match the notion of accounts. And so for those that don't know, accounts is kind of how we quantify the notion of multi-tenancy in a system. By default, all the users inside of an account can see each other and talk to each other, but by default, they cannot talk to anyone else inside of another account. Now, of course, we allow secure sharing, and you can read a lot more about that. I think it's one of the most powerful things we've done with being able to build out systems where there's separation of concerns and organizations and business functions all operating very seamlessly. But what's interesting here is that the fact that the NATS supercluster has multiple accounts, let's say A, B, and C, doesn't necessarily mean that the clients that would connect to these Leafnode servers have to be aware of that, right? They can actually not even expose accounts at all underneath the covers utilizing the global account, their own security domain, which I'll demo here in a quick second. But what they'll do is as they connect in, they'll use very strong high-level NATS 2.0 security, TLS, nonce challenges, ED 25519 signage of public claims to prove who this is. But that's all oblivious to all of the clients that are connected here. Yet once it's inside of here, it's bound to, let's say, account A, B, or C. And so if someone over here is also binding to account, let's say B, any client over here can talk to any client over here totally transparently, regardless of how big this supercluster is. And that means it can span multiple geos, multiple cloud providers, edge gateways, everything you can imagine. Now, Leafnodes, again, bind to these hub accounts, and I'll show you what that looks like. It takes a while to wrap your head around it, and we're becoming more aware of that. But once the light bulb kind of goes off, and when I show you how simple the configuration is, it becomes extremely powerful. Account A can also have credentials, and a local account can be, again, global or bound to an account, which I'll show you. And again, the security domain and how you want to exercise that can change so that the security model here is very different than here. But again, it's the same technology. It's the same thing that can be trusted end to end. And so a demo, I'm going to stop sharing for a quick second and then reshare right away for my, my terminal, but I think I'll do my whole desktop. Okay, can you guys see the terminal?
Yep.
Yes, okay, good. This is a live demo, so we'll see how it goes. But what I'm going to show is I'm going to show you I want to run a local NAT server, and I'm going to connect this to our supercluster, right, our NGS supercluster. And those who receive the email with the offer to get a free lifetime business level account, thousands of connections, Leafnode connections, all that stuff, and have gone through this, you guys are welcome to follow along at home, and you'll see exactly what I'm going to see. So before I do this, I'm going to go here and I'm going to say, I want to send a request into NGS. I'm going to send it into a service that I've imported that'll tell me my usage. And so this might look like something like this. Now, NATS NGS is an alias for me that just says point to NGS and use my credentials, Derek's credentials. So it's just a shorthand. I'll show you what that looks like. And so I say I'm sending a request, meaning I want a response, sending it to NGS.usage, and giving me my usage for the last 24 hours. And so you can see a simple JSON response that says, okay, this is what you're doing. Now what's interesting is, and it's nuanced, and it's not specific to Leafnodes, but I wanted to point it out, is what the system is doing is that every user of the system has NGS usage as an imported subject that I can send messages to. But the backend, which resides in a totally different account, and there's a secure handshake in between my account and the usage accounts and the applications that are doing the responses here, it actually is listening on ngs.usage.star, and you have to get a token permission to import it. And what it's done is it's only given me permission to import ngs.usage.mypublic_NGS account ID. Yet, because of the way I import that service, I can put it wherever I want. I put it in NGS usage. So now all of a sudden, everyone has the same experience. Everyone who has an NGS account can do the same thing I'm kind of doing here. And again, if you want to look at the alias, it's right here. So I'm just doing a NATS utility that RI talked about earlier, using this server, these credentials, and then of course it passes on that stuff. So again, interesting, but you notice it's a little slow, right? It's taking a little while to kind of get going. Now, if I wanted to use the local one, this is the underlying request from the NATS utility, again, that Ari was talking about. Typed in request twice, sorry. It'll say there's no servers. There's nothing going on here, right? And so what I want to do is I want to create a local server. And I want this thing to transparently but securely bind into NGS, but I can have clients just connect to this. And so I'm now owning and operating this server, even though Synadia and others are operating NGS. And I might want to change my security domain, which I actually do, because I'm going to say, hey, only applications that are running on this machine can get access to it. So I don't need TLS. I don't need a user password or any type of authentication. At least for me, I'm comfortable with that, right? The security in terms of the machine. And so to show you what that would look like, this is it. And so we're saying, hey, we want to solicit a Leafnode connection. We're going to solicit it from a remote that is residing here. This is a DNS setup that Dave and others will talk about later about how we do geo-pinning and cloud provider affinity and stuff, which is stuff we're happy to share with everyone on how we did that. Here's my credentials, which you saw from the alias. If you followed the instructions in the email and you actually used the NATS Connect as both the account and the default user, meaning you followed the email exactly, you just put this in instead of what I'm doing right here. And so I can now go over here and say, hey, I want to run a NATS server and I'm going to connect it to or use the leaf.conf, which we just looked at as my configuration. And so if you notice, it immediately said, yep, I'm connected to NGS.global now. And what's happening is that on the NGS side, everything that's coming and going looks like Derek's account. And everything over here is just, there's no authentication, authorization, TLS, it's just an open port. So now all of a sudden, let me see if I can hide this thing. I've got a little bar that keeps getting in my way from Zoom that won't let me, here we go, I'll just do it this way. So now if I do this, I do have a server that's locally running and this returns. And if you noticed, hopefully you did, it seemed very fast, right? Because we've amortized all of the cost of TLS and all of the complexities around the key exchange, the non-signing, all the stuff that NATS 2.0 does to try to make a extremely secure, forward-looking secure by default system with NGS, where NGS never has access to any of my private keys or passwords ever. So now all of a sudden this becomes very interesting, right? I now have the ability to own and operate my own server or a small cluster of servers, and I'm using a shared utility. And so if I started talking amongst myself just on my local computer here, no traffic would ever move to NGS whatsoever. I'm listening on Foo and sending to Foo. It's just using my own local server to do that. So this best of both worlds topology is kind of interesting to us. Now, what's interesting as well is again, we talked about the fact that even though this one is super simple, we can do multiple accounts. And so what I'm doing here is now I'm saying, okay, now my local server does have multiple accounts, A and B, and it has the ability to do authentication, right? Just simple user password. We're still soliciting the connection into NGS. We're still being represented by Derek, so it's in the Derek account when it shows up over there. But locally, we're going to bind to account A, which means that if someone's logged into account A, it flows to this TLS connection into the Leafnode. If it's on account B, it does not. And so let's see kind of really quickly what that might look like. So you can see that I've connected again to the Leafnode. You will see again, hopefully that this will not work, right? It'll say there's an authorization violation, A:A. Now if I say I want to publish to my local server, but using the A.A, meaning I'm not part of the A account, this should work, which does well. And again, if I do, let's see if I can find, here we go. Now if I'm doing a NATS request, again, using my local server, but I'm logging in as A, meaning I'm bound to account A, and I'm doing the NGS usage thing, this works exactly as it did up here. But if I go and I say, hey, I want to be part of BB, And again, accounts by default isolate all traffic. So this server is truly multi-tenant now with all of the users of account B and all of the users of account A. But when I do this, it'll stall and just time out because there's no rule to propagate that information to NGS through that leaf node. Now, of course, we can also say, now I'm going to say I have, again, 2 accounts locally, A and B, and I'm actually going to create multiple leaf node connections bound to the different local accounts. This one's going to bind to Derek, and this one's going to bind to an OSCON account that we set up for OSCON. Wally and I did when we did our talks and demos up there. And so if I go back and I restart the server, but I use now 2, you'll see it has 2 connections now. And by the way, if you really want to see what's going on, you can always add DV in, and it'll start showing you lots of stuff, interaction with the leaf nodes, sending the credentials, all of the things that are going back and forth. Leaf nodes are the only network topology that NATS has that is interest only both ways. So client connections are interest only, meaning they'll only send you something if you're interested. But every time you publish in a client, it always goes to the nearest connected server and then is processed there. Leaf nodes will never send data either direction unless there's explicit interest. So I'll do, just start up again with just without the DB. And now when I go and I say A, right, we still get the same thing that we saw above, except I have, of course, a new message and things like that. But now B is going to actually be scoped to the OSCON account in NGS, okay? So I haven't done anything. I have had 5 sessions, but nothing in the last 4 hours, last 24 hours. I've done a little bit of stuff because I was playing with this demo last night. So again, at the highest level, what I think we're showing, in my opinion, which is fairly straightforward to look at, is the ability to do things that most technologies just simply can't do yet, or they can do it, but it's extremely complex from a configuration, monitoring, management, keeping lights on perspective, which is we have a shared utility that has a certain security domain and an operator, you know, Synadia, let's say in this counts for NGS. I then decided on my own to extend that utility network that's global, all cloud providers, all major geos, and run my own server with my own security domain, even multi-account, right? So that I can actually be mixing and matching. And again, what's happening here, it's very trivial to kind of skip over, but what's happening here is that a message is being presented to my local server that I connect to very quickly with no TLS. It understands that it has to route it because there's interest in this subject inside of my account that's represented by the service account inside of NGS that are running all over the world. The distributed queuing and geo pinning technologies that we have in our global superclusters finds the closest one for my request. It moves from my account, my local account here, to my Derek account in NGS. It crosses an account membrane in a secure fashion into the usage account, which gets a ngs.usage.derek request. It says, oh, Derek wants his usage for the last 24 hours. Puts that all together and simply responds to the reply subject, and it makes it all the way back to here. And so being able to depend on that type of a technology, the ability to mix and match shared utility SaaS type offerings with owned and operated type deployments, totally location dependent, totally secure, you know, being able to be as agile as you need to be with the applications that you're trying to do, we just think it's incredibly powerful. And so we like it. We think it's a great addition to the network topology type stuff that we see. And yeah, we're really excited about it. So I'll go back now to demo. We'll just do a Q&A type scenario, and I'll see if I can find any questions if anyone has any. If not, we can catch up with some space and time and move on.
I don't see any questions yet in the Q&A. If anybody has any questions, use your Q&A button on your Zoom browser.
And we can obviously answer these on the Slack channels as people try to get their feet wet. But it's incredibly powerful, but so approachable. And from the things that I've seen out there, just drop dead simple to configure and to operate. And just like the core of NATS technology from all of the topology and topology connections that they self-heal themselves and they reassemble themselves. They also gossip that information back and forth to clients, and Leafnodes are no different, right? So if all of a sudden the server that I was connected to inside of NGS went away, the system would automatically try to re-heal itself, re-solicit the connection, re-hook it all up, all of that in the background. You don't have to worry about it. So yeah, it's pretty cool. So Thomas says, how much of Jetstream preview works over Leafnodes? That's a great question. And believe it or not, even though Jetstream is by design underneath the covers, multi-account aware, NATS 2.0 aware, and we've actually just put in the configuration for things. The way we started rolling out at the beginning was you would run a server just with a global account and say -JS. As a matter of fact, the server I was just running is a Jetstream server. So I could show you that if you want, or we could wait till later. And so what happens is that Jetstream is enabled for the global account, but again, it's connected into NGS on my behalf inside of the Derek account, which means that now globally on NGS, my account now has Jetstream enabled, being powered by this Leafnode. And what you can imagine, if you remember Leafnodes being hubs and spokes, we might be overusing this, but we think it's very, very powerful, which is you can utilize these Leafnodes that are running JS just to be extensions to your storage. So when we release Jetstream clustered, right, you'll be able to have a core cluster or core supercluster, and it might have some storage resources and memory resources that it's pooling between all the servers for Jetstream based on all the accounts that are trying to access it. But let's say, you know, Kyle, who I can see on the Zoom gallery, says, I need more. I want to have more disk storage. I want to add, you know, a petabyte of storage. Instead of have to change that core cluster or core supercluster, you can actually extend this and say, no, we're just going to run a plain leaf node, no accounts, nothing crazy except that remote solicitation into our core cluster that binds to Kyle's account. And we put a petabyte of disk and SSD or flash memory underneath of it. And now all of a sudden, Kyle's account has a petabyte more of disk space than everyone else. So we're using both of them. They're mutually exclusive technologies, but they are helping each other quite a bit. So we have another one that's a little bit longer. So I think the general gist of this question is do we understand the concept at a level that could enable things like GDPR? And the answer is yes. So at the beginning presentation where I was doing the welcome, I said location independence mostly. And John, I'll read your question more once we move to the next presenter, and I'll put some more detail in there, but I just skimmed it very quickly. But we do have the ability to very cognizantly understand permissions within accounts and users of, you know, what you're allowed to send to and receive from. Alberto was demonstrating that with WebSocket. But we also have the notion of where are you allowed to connect from? What times can you connect from? Things like that. And so we don't have packaged solutions for it, but we think we have all of the pieces similar to how we laid the groundwork for WebSockets coming to fruition with what we think is a very compelling solution. We have the same thing for this, and this is very top of mind for us. A lot of the team members are thinking about data ownership and the ability to control where that data moves, either based on, which is, to be frank, blunt instruments. GDPR and the California initiative around data privacy are very blunt, but we don't think it's going away, right? And we do believe that it's going to continue to evolve. And so we're not going to be going backwards. We're moving forwards, where we're going to have more refined technologies that allow people to control data that they generate, right? And so we are very trying to be on top of that and think through that. And so again, I'll respond directly to your thing as well. Also the other way, have Jetstream only in the Leaf. Yes, so Thomas, that's matter of fact how we run it today. So if I ran a server, which I can show you either now or later on in the day, the exact same Leaf node over I said, if I just put a -JS on the end, it would spin up, you know, Jetstream locally on my server using all of my resources on this machine, but it would be presented to any user in the Derek account on NGS from any connection worldwide, any cloud provider, any geo. So yeah, we can definitely do the opposite. Thank you. I'll let Ginger take back over and we can move on. But play with Leafnodes. We think they're going to be an amazing addition to the ability to construct arbitrary topologies and be able to scale them and modify them without having to touch the endpoint applications. They can continue to exist because again, it's just NATS. It's just a client connection, and it doesn't matter if it's connecting to a route server, a Leafnode server, a supercluster server. It all works exactly the same. So thank you.
Okay. So this is kind of a quick walkthrough on how to get started with NGS. As Derek mentioned, it's a single NATS URL to connect everything. And it's a global, in terms of the topology, it's a global NATS supercluster that spans across 8 different regions, 3 different clouds, AWS, Google Compute, and Azure. So just a quick walkthrough on getting started. If you got the email, and you can get the tool from this script that will give you the NGS and NSC utilities. If you can easily get started with a free account to start sending messages. In this case, we're initializing using the Synedia operator and NATS Connect account. Internally, this is using all the NATS v2 credentials and JWTs in order to authenticate with the server. If you look at the credentials format, you have the JWT and also your private key to connect against the cluster. So hello world, just using the NATS box tool, which you can find on this URL. We also have a Docker image that you can use, in this case, to mount the credentials that have been generated. So I can use Docker run into the Synedia box to get quickly start sending messages. Connect to ngs.global. And publishing using those credentials. World. This is going over the supercluster, and in this case, since I'm in San Francisco, it will be against the AWS US West 2 region. So yeah, quite easy to get started with NGS. In terms of the Go API, we have you have to pass the user credentials to the when you connect. Derek will mention in the with the command line tools, but we have a couple of utilities as part of a couple services that you can use to confirm your connection. You have an echo service that will just give you an echo response with the payload that you sent. You can also get the usage. This one, the payload is not important. So you can get some stats on your usage from NGS. And also following up from what Derek mentioned about the Leafnodes, something very cool that you can do with NGS is combining with the Leafnodes type of topology. For this type of topology, you need to use at least the developer account. So you can go into this the pricing page from Synedia and get a developer account, which will give you the account to be able to start sending, to be able to use Leafnodes if you follow the instructions from the email that it was sent to you. And I want to show you as an example of so yeah, this is instead of with a Leafnode, instead of connecting against against connect.ngs.global, you can just use localhost as Derek showed. So using the same supercluster that I shared earlier, we still have the supercluster that was using the gateways to create like a supercluster to be able to send messages across regions. We're going to do something similar, but using a different topology. In this case, instead of using the supercluster and having all the gateway connections one to another one, instead we are connecting the different regions, but using NGS itself as a service. So in terms of Helm, you can see the difference. On the left side, we have the supercluster where I need to specify what are the endpoints, all the IPs from all the members, all the clusters that are part of the supercluster. On the right side, you have the single shared configuration that you can use to stitch everything together. So these both allow to be able to publish a message from these different regions and be routed properly. So for example, in case here at the top, we have San Francisco, a container running in San Francisco. Here you have it in New York. We try to connect, we'll get a very different server IP. And we can create start a subscription, let's say, hello world. And we also, we're able to use, send messages to this other remote region without having to use the supercluster type of topology. So yeah, the Leafnodes are super flexible, and you can leverage some of our superclusters and all of the regions that we have to be able to simplify some of your deployments as well. So for example, from here, the region that is going to resolve is AWS US East 1. From San Francisco, I would have been connected to US West 2. So yeah, this is a short demo of NGS. Definitely try it out. Definitely, I think Leafnodes make it a lot more fun for playing with different network topologies. Thank you.
Thanks, Wally. And yeah, what I think Wally was trying to show the power there is that, you know, you don't have to direct connect to NGS. You don't have to actually utilize it, you know, directly to get a tremendous amount of value. You know, if you're running Kubernetes clusters and you want to utilize NATS inside of those, but you notice that you're running Kubernetes clusters in different regions or in different cloud providers, instead of you having to set up all of that infrastructure yourself, you could see that it's a radically simpler setup for Kubernetes to just say, just run a single server and create a Leafnode connection, and then all of a sudden you have global connectivity. So we think it's cool. We think there's a lot more we can do. So interested in how you want to use it, how things work well and you like, or things that you'd like to see us to do. Some of the things we're looking at is the notion of zero trust, where the local server that you're owning and operating would have the notion of encryption, where you only have the keys to that, such that NGS can be truly treated as zero trust, meaning you trust it to keep things secure and to route messages appropriately, but we wouldn't be able to see anything or interpret anything inside of the payloads if it was encrypted before we ever got it. So those are some of the ideas we're thinking about as we kind of go forward, but love your opinion and feedback.
Running NATS globally. This is an ops perspective on the whole shebang. I'm Dave Kemper, DevOps engineer. I created the NGS cluster setup. Phil Pennock is also one of our ops folks. He had to drop off. He's the guy who I wish were here when we set up the NGS clusters. So we have, let's see, NGS, we've already kind of introduced, Wally gave a nice introduction of getting connected to the global service. We, as ops people, we use the same components, the open source components that are available to everyone else. So in many ways, we're users just like you all. As ops folks, however, we are also a conservative breed. So instead of running fast and breaking things, our motto is more like, hold on, wait a minute, let's go test this out. So I wanted to go over a bit on how we actually do the deployment of the global service. It's a little bit difficult to anticipate from the user audience what you may or may not be interested in. So I'm presenting more of a survey of how we're using different pieces. I want to make sure that we have plenty of time for Q&A in case people are interested in digging in on specific pieces. And if nobody's interested in digging in on the specific pieces, then maybe we can get a little bit more onto our scheduled times. So, geez, my up and down arrows are a little bit flaky. NGS compute superclusters. We've been talking superclusters a lot. We have a production and test environment. That should not be a surprise to anyone who's in the ops world. Each environment spans the three major cloud providers, AWS, Azure, and GCP. We could add more, but that also comes with operational costs of making sure that they're working kind of the same across the different pieces. That's always a challenge. All cloud providers are represented in each environment. Our test environment simply has one cluster of each. Our production environment doubles down, and in one case quadruples down, on different clusters in different regions across the world. There are also localities where clusters are relatively close together, like on the West Coast. Each cluster has its own set of API servers and operators. We have been talking a bit about the newer security models that we support with the seamless multi-tenancy. But of course, for our production and test environments, they are completely separate and their vertical stacks are duplicated. Each of these environments has its own global connection URL. For production, obviously, that's connect.ngs.global. I won't tell you what the test one is, but of course, it's protected against the various TLS and account security. As Derek mentioned, we have geo-routing that is connecting you to the nearest cluster. We use a third-party DNS provider, but we're responsible for providing the metadata that it uses to make these decisions. And I can drill down on that if people are interested. So within each cluster, each compute cluster is a cloud provider managed Kubernetes cluster. We decided to go back in the day with a managed provider because with limited ops budget for people staying awake, having the managed solution made sure that our control planes were under the watchful eye of Amazon and Google Cloud. And it was also a relatively easy thing to set up and spin up. Of course, this was, I think at this point, a couple of years ago. And they continue to make the process easier as they streamline the operations pieces. We ourselves use the NATS operator, and it maintains custom resource definitions for a NATS cluster definition. It deploys server pods. So within each server pod, we have a number of containers. One of them is obviously the NATS server, but there are some other support pieces, including the Prometheus exporter. In steady state, each NATS cluster has 3 NATS servers. We can scale that horizontally. upping the number of servers in the NATS cluster, and we can scale it vertically by updating our Kubernetes node pools to have beefier machines. One of the little tweaks that we do for NGS that many people don't take advantage of for their own clusters, we use host ports to expose the NAT server pods. Our intent is, as much as possible, to keep Kubernetes out of the data path. Now, that's, some of you may be chuckling because already we're talking about deploying a NAT server wrapped in a container on a cloud server with a Kubernetes Kubernetes networking overlay on top of that. But this still lets us play in the Kubernetes world, but cuts some of the layers out. So the ports that we're exposing on the NAT server get exposed on the public IP address of the node that it's on. But the implication there is you can only have a single NATS pod on a node. And that, again, is why the horizontal and vertical scaling is important. We do rolling upgrades by also a little differently. We still use the NATS operator, but we deploy 2 NATS clusters side by side. So we've got the old cluster running. We deploy a new NATS cluster with a pointer to the new NATS server pod that we want to deploy. And that side by side, the new cluster now has a temporary route to the old cluster, so that now they become a 6-node cluster. They do their sharing, their state sharing, and then we put the old NATS cluster into lame duck mode, which basically migrates the client connections to the new NATS cluster. And so the goal there is that we strive for at most 1 reconnect during a rolling upgrade. If you simply added a new server and removed one, added a new server, removed another old one, it's possible that you could have your connection migrate to another old node and then be migrated again. Now, of course, everybody is going to be writing their clients so that they do the automatic reconnection. But we still, as a global service, we try to go the extra mile to be as little, to give you as little disruption as possible. Also within each cluster, we have a custom Kubernetes observer that is syncing the IP addresses of the active NAT servers that we have to our third-party DNS provider. And so from the top down, you've got the single connect address, and then based on the geolocation data that we give it, it will resolve to a specific cluster. And from within the cluster, we are keeping those IP addresses in sync. And then additionally, we have TLS certificates that are managed in cluster by Let's Encrypt. So once again, we take the standard Let's Encrypt with the plugin for our third-party provider. We wrap that with a little bit of our own component. We run that as a cron job, so every day it wakes up and says, hey, do these certs need to be renewed? And then if it does, it goes and proves that it owns the DNS records. And then it goes and takes the updated TLS materials and puts them in the Kubernetes secrets that the NAT servers themselves are requiring to enforce TLS. In addition, in the NGS compute cluster, as I mentioned, there are multiple Kubernetes secrets. Some of them are TLS. There's also a secret, obviously, for the third-party DNS provider so that we can do that IP update. We've got some config maps for state and interoperability of the various working pieces that we've provided. We are we're exporting our logs to yet another third-party provider. That gives us an elk stack, so we can use the Kibana dashboard to go look at events that have happened. Our intent is basically to get the raw logs off of the individual clusters as soon as possible into the global store that we can then write Kibana dashboards and alerting off of. We also install Prometheus server for in-cluster, for the monitoring of the cluster itself. So that is pulling the NATS metrics data as well as what is available for Kubernetes infrastructure itself. I mentioned in the pod that we deploy for the NATS server, we've got the Prometheus sidecar for it as well. And then we can we can point Grafana onto those various Promethei for global monitoring. We also have miscellaneous pods for visibility. So for ops, we tend not to want to go directly into running server pods, NAT server pods. So we've got a daemon set of pods for each of the nodes so that we can kubectl exec onto it in case there are any issues so that we can take a look. So there are also ancillary components that we don't deploy in cluster. We basically have like Linode servers that handle some of this. We have account servers backed by a PostgreSQL that's managed PostgreSQL on G-Cloud. That's the account servers are the API servers that are managing all of your tokens and your identities. We have health monitor instances that are globally dispersed. Those are on Linode. We also have usage servers. So in a couple instances, you have seen usage statistics. So there are servers that track that. Surveyor and Link Prometheus and Grafana instances. So you also saw, this is another instance of ops being conservative. So we have our original Prometheus layout. As Ari mentioned, Surveyor uses NATS to monitor NATS. And so we are also very interested in what is happening in the system as we're doing rolling deployments. And so we don't necessarily want to be dependent on the NATS that we are deploying now in order to do our monitoring. You know, many different ways to do the same functionality. Overall, there are certain friction points. Managed solutions can have rough edges. It's very convenient to spin them up, and it takes some of the management headache from you. But some managed solutions give a node a public IP, others do not, and that changes over time. So for example, AWS used to not give the public IP. Now it does by default, but Azure does not, although now that I think there's a beta feature for it. Some managed solutions support multiple node pools. Azure does not. Again, they've got a beta feature that will allow that. Divergent sets of timing around availability of supported Kubernetes versions. Kubernetes is under active development, and so you will often, you'll get notifications from the various cloud providers saying we are no longer going to be supporting Kubernetes 1.11 or 1.12. So you're always chasing the versions that are being supported. If you were to deploy Kubernetes on your own and manage the whole thing, then you would be free to stay on whatever version you wanted. The managed solutions make cross-cluster custom network topologies difficult. We are, as I said, spanning 3 different cloud providers. Managed solutions, we don't really own the VPCs and the security rules. So when we want to open up ports, it gets to be, kind of an exercise in going to the console and opening them up. At the bottom line is there is no standard Kubernetes deployment. There's enough wiggle room between the different providers that on the edges, you always have to be careful. So you always have to test first to see what is available for your particular cloud provider. There are also many layers. When things go wrong, it's challenging to diagnose. You have a network glitch. Is it the VM? Is it the NAT server? It's usually not the NAT server. Is it going to be Kubernetes? Is it going to be your DNS provider? it's all very complicated when there's a glitch. If you leave the happy path, things can be very unhappy. Host ports, they're not idiomatic Kubernetes. Our use of it is kind of a wart that has downstream effects. And as I mentioned, have fun opening ports on 3 different cloud providers for 3 different stacks. At the end of the day, you still have to end up writing a bunch of glue for management, let alone cross-cluster automation. And so now you're seeing tooling like Helm filling in that gap. And again, because we are a conservative bunch, it takes us a while to kind of change what's currently working into the next generation. So Kubernetes is a sweet spot for HTTP services with dispatch routers in front. Our NATS servers with the TLS upgrades that happen on your existing connection, that's not the best fit for Kubernetes, which is again why we chose to do the host ports. So I'm already running over a little bit of time for the material that I wanted to, and as you can tell, this was just like a really quick survey of the components that we have to deliver our services. So I did notice that there were some questions at the time. I apologize, I didn't have the ability to look at them at the time, but we'll see if I can get to them during the next discussion. Other than that, are there any live questions, or does anybody want to pop in? Okay, thank you very much.
Thanks, Dave. And for everyone listening, even if something like NGS doesn't feel like it might be something that you'd want to utilize today, I think the experience that Dave and the team have garnered over rolling out, upgrading, and running very large scale NATS clusters like this is hugely valuable. So we're happy to share. Please reach out and get hold of us. But a lot of good lessons learned and good practices from Dave and the team. So thanks, Dave.